Hey, welcome to the second presentation on statistics for middle school in the national curriculum. Oh, statistics. Very similar to the first screen we had last time. What statistics mean? It's an area of mathematics which deals with collection and analysis of data, but it can mean something else as well. Here we are here. It can mean actually the calculation of values to describe a data set in terms of numbers, not graphs. We said, come up here, a graph is worth 1,000 figures. It really summarizes the figures or the values or the numbers very well. But we also want to do some calculations with those figures to describe various things. Have a look around the screen. Here's an interesting formula here. I don't want to frighten you. You won't be using that one for a while. That's to measure how spread out a data set is. It's called the standard deviation. Down the bottom here, there's an interesting formula, another one very similar, and then another one there. So we're going to be doing some calculations, adding things up and trying to describe various things about the data set. And look over here, the mean is 8. Does that mean the number 8 is mean and nasty? No, not really. A mean is a mathematical term to describe something about the data set. And the median is another term. And we've seen the mode before. And these values here are going to be numbers that we're going to calculate, or statistics we're going to calculate to describe the center, the central nature of the data set. Where is it? What's the middle of it? Give people an idea. If they're not looking at the graph and not looking at the numbers, the raw numbers, we can just give them a figure to give them some indication of where the center of the distribution is and maybe how spread out it is. So these values that we calculate from a data set are called statistics as well as statistics meaning the whole area of mathematics involved in all that stuff. Okay, so come on down, let's have a look at it. Here we are. Here are your scores. I hope you're happy with them for the last 5 maths tests. Gee, you're not a bad student. You dropped to 65. But you went right up to 95. And so how are we going to describe on the average how you go? And I think you probably already know this. You could add them all up and divide by how many there are. And that's called the mean, sometimes called the mathematical average. And, what's this little dude here? Now, the book doesn't do this, but I reckon you're big enough to use some sophisticated little formula like this. It's impressive when you write that down. What's it saying? That is a Greek capital sigma, S for sigma, which means was used as sum of in mathematics, summing up, adding them all up. What are we doing? We're summing up all the x values. X stands for the variable we're measuring, all the data points. So here it's 70, 65, 75, 95 and 80 are the x values. We're going to add them up and divide by how many there are. And the symbol for the mean, the answer to that, is called x bar because it's got a little bar over the top. That's a symbol for the mean or the mathematical average of those scores. And I guess you've done this before. So x bar is, let's add them all up. And if you add them all up there, you'll find you get 385. And how many scores were there? There were 5. And if you divide that out, you get exactly 77. So your mean, your arithmetic mean, was 77. Okay, so is that a fair description of how you went? Somewhere in the middle there? Is that describing your middle score pretty well? I think it probably does. Well, what's going on over here then? What have I done? Well, this is similar to what we did with the 7-leaf plot, isn't it? We've put the scores in order. And the median is another measure of the center. And we take the score that's in the middle as the median, 75. So there's not much difference between your mean of x bar of 77 and the median of 75. I guess you'd like to quote 77 and sound a bit better. Okay, but we sometimes will use, and here's a question for you. When do you think the median is a better measure of the middle of the data set than what the mean is? you can already see that here the mean is a bit higher, 77, and than 75 when you put these in order. And I wonder if you can see there's one data point which might cause it to be bigger. Can you find it there? Okay, we've got one score, here it is 95, and over here 95. And if you add that on as you do with the mean, that gives you a little bit of a boost in your total, doesn't it? It doesn't do much here because the median doesn't add on all the scores. It's not affected by the size of the scores as such, because it's a middle score. It doesn't add on that big number 95. So you might watch out for that when you've got some very big numbers or very small numbers in your data set and you do the mean. You'll find it might go quite a bit higher, or just a little bit higher, or a little bit lower if you have a low score. Imagine if over here you only got 55. That, because it's added on, will pull your score down a bit, but it wouldn't actually change the median much, would it? Because you just move to somewhere between these two would be your middle then. Well, that'll look better then. So just keep that in mind. The mean as a measure of the centre can be affected by a few high or low scores because it actually adds them on and it affects your total quite dramatically. Okay, what's happening down the bottom here? Oh, well, we have a nice vertical column graph, and what have we got there? I think we should make a list of this. The x values are 6, 7, 8, 9, and 10. But hang on, we've got a problem. We've got two sixes, 2 7s, but 3 8s. So we can't just add these up here, can we? Because each one had a different frequency. 2 6s, 2 7s, 3 8s, 4 9s, and 1 10. Oh, so how are we going to add them up? Well, here's a clue. Do you reckon you can work it out from this? Again, I want you to use this little formula because it's not too hard to understand. It says we should add them up, Greek capital sigma, of the frequency times the score. Oh yeah, that's multiple addition again, isn't it? Instead of saying 2 6s, 6 plus 6 is 12, I'll multiply 2 by 6 and get an fx column. Just get rid of that. I'll get an fx column, which is 12, and then 2 7s, 14. The 8s, if you lined them all up, would add up to 24. 4 9s is 36. 1 10 is 10. So can you see that if they occur a different number of times or more than once, you actually have to account for that in your addition. You can't just add up these columns. They occurred a different number of times, not just once each. So if you added that total up there, I think you get the number 96. So your x bar is the sum of fx, here it is up the top here. So that's 96 divided by how many scores? 12 scores. We better total that column there to see how many scores we've got. We've got 12 scores. So n, standing for the number, n for number of scores. Again, mathematical notation is usually very commonsensical. Common sense, 12 into 96 goes 8. So we have a mean of 8. And that's what we said before. The mean was 8. The mode is 9. That's the most frequent score. And I wonder what the median is. Now, that's a middle score when you place them in order. And we've got 12 scores. So we better try and do that. So I'm going to scrub this out. We're going to try and do the median now. And that was the little formula down the bottom right-hand side of the original screen. You might like to go back and look at that. So I'm going to put the scores in order. 6, 6, 7, 7, 3 8s, 8, 8, 8, 4 9s, 2, 3, 4, and 1 10. Okay, so that's our data set. So, sorry about that. So here n is 12. Now half of 12 is 6. 3, 4, 5, that'd be that score. But hang on, it's got to be in the proper middle. There's 5 scores below that, but above that there are 6 scores. And so that's not in the middle. So an even number of scores, we've got a problem. We halve it, so let's go to that. We'll go halve it. So that's the 6th score. But then you've got to go halfway between that one and the next one. So that's the 6th score. The actual proper middle is somewhere in the middle of those two. And what we do, the median is the 6th score plus the 7th score divided by 2. It's actually the mean of the middle 2 scores. We're going to go halfway between the two there, so that there's the exact number of scores above and below. So we've got to go halfway in there. Here it doesn't matter because it's 8 plus 8 on 2, which is 8. Okay, because both the middle scores there are 8s, so their mean is also 8. So we have, come over here, the median is the middle score when they're placed in order, and for an even number of scores, a bit harder. Have a look up here. You only had, we didn't have the 55 there at the beginning, so we have 5 scores. So if you added 1 is 6 and divide by 2, there's your middle score. It's an exact score. You don't actually have to average the middle 2. So median, be careful if there's an odd number of scores. It's one of the actual scores. Take the number 5, divide by 2, and that's a 2.5, and take it up to the 3rd score. We'll do some of that in a minute. Okay, but they're the 2 comparisons here. So in this one, the median was 8 and the x-bar was also 8. So the 2 were the same, so nothing to choose from there. But later on we will be asking you, what is the best measure in all circumstances of the centre? Is it the mean or is it the median? And it may be one or the other as circumstances change. I want you to think about that, and particularly to think about if I have a very low score or high score added on, that will affect the mean and give a different impression of that centre value compared to the median. All right, think about that. Talk to your classmates and your teacher about that one. Let's go on now. So what have we just been doing? We're measuring the centre, trying to give people an indication through a calculated value based on the data set, and that's called a statistic, so that we're indicating something about that distribution of scores when we don't have a graph perhaps, and we just got a mass of scores. So what is the centre? It could be the sum of the data values over the number of values and called x-bar or mean. Okay, that's often a good measure. So x-bar is the sum of all the x's divided by n. I want you to start using that. You're not too young to use that little formula. It's not hard. Just remembering that in mathematics, that is a Greek capital sigma, means sum of. Okay, means you're adding them all up. The median is an alternative and sometimes a better way of indicating the centre, and it's the middle value when you put all the scores in order. Just watch out for is n odd or n even. If n is odd, there'll be one actual data point, which is the middle. There'll be equal numbers above and below it. If n is even, you've got to divide by 2 and take the average of that one and the next one. Okay, we'll practice that. The mode is the score which has the highest frequency, occurs most often in a data set. And you can see already that maybe the mode is not a good measure, because in your scores for your maths test, every one of those scores only occurred once. There was no mode. So quite often we don't use the mode for that reason, that all the scores are only occurring once. And also, it is possible that there might be several modes. Several scores might occur 2 or 3 times, and picking the ones that occur 3 times, there might be several modes. So that's another reason we generally don't use the mode very much to measure the centre. All right, get the idea? Let's go down and try some now. Exceptional footballer scores the following goals for a school during a season. So you can see what sort of football. It's soccer here. And the mean, I want to calculate the mean, the median, and the mode, and see what each has to offer about describing her performance. Remember, we're calculating statistics here. Values which will describe a number, which will describe the centre of the distribution of scores. Okay, so what are we going to do? We're going to do the mean. So we're going to write down our formula. They each occur there, so we're just going to add them up. Not a tabulated data. So here, sum of x over n. So here, add them all up, it's 45 divided by 20, it's 2.25. Or 2.25 goals per match. That's her average or mean. Okay, you can't kick 2.25 goals, but you can still quote that as a mean, because the understanding is that if that's what you kicked every game, you would get the same total. That's okay. Obviously, you can't, it's understood, and you should keep this in mind, you can't get that particular value. But that's what it averages out to, if you'd like to say, on the average. So that's why we're trying to say, what's the single score, which if she got on every time she played, would come to the same total. So that's your mean. That single score, which obtained n times, would give the same total. Keep that in mind. So if we use an ordered data set now, and that's this one here, if we do that, then we know that there are now 20 games, so 20 divided by 2 is 10, and we've got to average that and the 11th one. Okay, so the 10th one is this, and to keep the number of scores below equal to the number of scores above, it's got to be the average of these two. It's got to be in there. Okay, so that's a little fiddly bit for an even number of scores. Divide by 2, it's then the mean of that one and the next one. So it's the same number here. 2 plus 2 on 2 is 2 goals. So the median is a little bit less than the mean here. And the mode, of course, is 2 goals, because if we go through the whole data set, that's the number that occurs most often. So why is the mean a little bit higher? Look up here at the data set, and if you have a look down here as well, you can see you've got a few up there which are quite a bit higher, okay, than most of them. And when you add them on, you get a boost in your total. Okay, the 4s and the 5s are going to boost your total up a bit. And the mean actually adds them on, whereas the median doesn't. It just puts them on the end, and this might move up a little bit, but it's still in the 2 range. Okay, you might think about that as you do these next problems. The mean may shift due to a few high or low scores, or maybe a bit higher or lower than the median, because it's adding on those scores that might be lying out from most of the data set. All right, let's move on. Okay, here we are. In the last 7 matches, basketball has scored these points in a basketball match. These screen clippings are from Hayes and Harris. You should grab that Year 7 textbook. And they like the sport, don't they? Find the mean score for these matches. So what we're going to do is, hang on, we'll just go back now, is add them all up and divide by how many there are. Okay, so add them all up and divide by how many there are. Okay, so when we do that, there are all the numbers, divide by 7. The mean is 21 points a game. Find the median. Okay, we're putting them all in order. And when you put them all in order, there we have it. There are 7 games. So 7 divided by 2 is 3.5. So that's the 4th score. Take up the middle score is exactly one of the scores of the data set when it's odd. Okay, and so the median is 22 points. All right. So if you look at that, what can you say? Well, the middle here was 22 according to the median, the middle score, and the gap there was up to 29 was 7 points lower. But look out, that 11 has pulled our total down, hasn't it? Because it's 11 points lower. So because she went lower quite a bit more than what she went higher, the mean is a bit lower than the median, okay, because it's actually going to add on all the values that you've got there. And if you drop one low, and you'll find this in your maths test, it's going to be hard to get your mean up because it's adding on that score. There's not much shift here in the median for those scores because it just doesn't take account of how big the score is. It just moves up and down in the middle there. Okay, think about that. Now, if the basketballer now scores 45 points, so you're adding on 45 to the previous total in the next game, you now have 8 games, it's 24 points. Okay, it's boosted the mean. Why? Because you've added on another point right out at the end, 45. Okay, let's see if the median moves much. So this time it's halfway between, there's 8 scores. So here, 8 divided by 2 is 4. And then it's the mean of the 4th and the 5th score. So here, halfway, divided by 2 is 4. So then it's the 4th plus the 5th divided by 2. So it's in here at 22 plus 23 on 2 is 22.5 points. It hasn't moved much, has it? The median before, come back up here, was 22. Now it's 22.5. It's just moved along that middle part a bit. Why has the mean jumped to 24? It actually added on, look at it here, that big score, 45, which was way off the end here. So the mean actually took account of the size of that score. The median didn't. It just took account of it's another score, so it moved up a little bit. So the median resists the changes of adding on a few or one even, very large or very small score. If it's a very small score, it's going to drop your mean quite significantly. If it's very large, it might boost it. So do we want that? That's a decision for your future statistics career. Do we want a good centre? And what is a good centre? One that's gone up because of 1 or 2 very high scores? Or do we want the middle when we put them in order? Okay, so have a think about that, particularly as you do these next exercises. All right, 16D1. So I want you to, throughout this, think about what you're doing and compare your mean scores with your median and see what's happening. If the mean is higher or lower than the median, and not the same like on the first screen, the mean and the median were both 8. If it's not like that, why is one higher or lower than the other? Can you have a look and study that? All right, well, I've got some questions. I think they're a total of 12 questions. So pause the presentation and have a go and check periodically 2 screens up to check your answers so you're not perpetuating an error. Make sure you're getting them right. Okay, so I'll go on to the next window now. And there's up to question 9. And don't forget to look at the frequency. These are all occurring at different numbers here. So take account of that like I did back in the example. And let's go on. There's the 12 questions now. All right, so I'll show you the answers to those from Mark Your Work. And there's the first 7. And there's the next ones up to 12. Okay. And now we want to move on. Right, there's one other statistic we might look at, and that's how to describe the spread out nature of the data set. So this is a calculation of a value to describe the spread of the data set, so it's called a statistic, and the statistic we're going to work with here is the range. The range is the highest value achieved minus the lowest. There are other more sophisticated measures of the range of a data set, but they'll be later on. All right, so we've got 17 students who have been home from sick for different reasons and for different lengths of time. Here are the lengths of time the students were away. Find the range. So the range is the maximum, which is 9 days. Okay, there it is there. And the minimum time away was 1 day. So the range of this data set is 8 days. Okay, so students are away from school, ranging from, if you like, 1 day to 9 days. It's got a range of 8. So the range is a statistic calculated from a data set which describes the spread. All right, fairly simple idea. Let's go and do some. Okay, so 16D2, there are only these 4 questions. Be careful, you want the higher score minus the lower score. Fairly simple idea to describe the spread of the data set, and it's called the range. All right, and some of these require calculating the mean, median and mode as well. And all that little bundle of statistics do give people an idea of the data set without looking at masses of figures and without the graphical approach. So just throw a few values at them, and if they know their maths pretty well, they get a good picture of what's going on. All right, so we'll come to the answers now. Okay, so there are the answers, and that's the end of the presentation here.